Got another organic mechanisms question for you to try. So we're up to number 5 now. So there it is there. So if you want to have a go at that, pause the video and then play on when you're ready for the answers. Okay, so the first thing I'm going to do is write the overall equation for the reaction that's taking place between methane and bromine to make bromomethane. So there it is there. So before we go into the actual mechanism, might as well say what it's called. So this reaction mechanism is radical substitution. Okay, so now we're going to break it down into the different steps. There are 3 different steps for this mechanism. The first one is called initiation. So in the initiation step, the bromine molecule is attacked by the UV and the covalent bond between the 2 bromine atoms breaks and creates 2 free radicals. So we represent the free radical with the dot there, which represents the unpaired electron. So we'll talk about the type of bond fission that's occurring because it's relevant for this stage. So if you think about, I'll just draw up a very simple bromine molecule here. Okay, so there's just the covalent bond between the 2 bromine atoms. So the UV splits it in such a way that each bromine atom receives 1 of the electrons from the covalent bond that's broken. So it's homolytic fission, it's the breaking of a covalent bond where each atom receives the same number of electrons or each atom receives 1 electron. Okay, so moving on to stage 2 now, so propagation stage. There's 2 reactions taking place here. So the first propagation reaction is where we take a methane molecule and it's attacked by a bromine radical. Essentially, the bromine radical wants to pair up this unpaired electron. So it gets the electron by taking a hydrogen and the electron with it off the CH4. And so that's going to generate an HBr molecule. And what's left is a CH3 radical. So there's an unpaired electron left on this CH3, and so that's now radical. So the second propagation reaction is where you take a methyl radical, so that's just been formed. It attacks a bromine molecule and it gets its electron by taking a bromine and the electron with it. So that's going to generate CH3Br and a bromine radical. And the final stage is the termination stage. So basically all we need to do now is take any 2 radicals and join them together. So you could take 2 bromine radicals and that will form a bromine molecule. So that's one you could have. You could take a CH3 radical and a bromine radical. That's going to make CH3Br. You could also take 2 methyl radicals and they would create ethane, C2H6. Okay, so just finish off by talking about why this isn't the best method to make a single substance, so in this case bromomethane. Well, one of the answers is here. So you can see there's one of the termination steps generates ethane. Obviously that's going to be a contaminant. If you're trying to make that, you don't want that. So the other reason we can give for this not being the best way to make bromomethane is the fact that we've got a bromine radical that's been reformed in the second propagation step. So what that can do is that can strip out another hydrogen, take the electron with it, and that's going to generate ultimately CH2Br2, so dibromomethane. Obviously if the bromine's still hanging around in excess, then it's going to take the next hydrogen out, so you'd get CHBr3. And ultimately you could end up with CBr4. So what we're going to say is further substitutions can occur.